Okay, we're on the room. Everyone can hear us in the room. Oh,
yeah. Can people hear me? Okay, I just start talking. Hi, I'm Pam. I'm part of the research engineering group at the Alan Turing Institute. I work together with 5 of my research engineering group colleagues on the Trustworthy Identity project. Tim and Ed are in the room with me. I think Luke is attending online, and Sam and Lydia can't be here with us today. So the topic of my talk is a challenge response protocol for Trustchain. So before I'll dive into the challenge response protocol, I should provide some context. So Trustchain is our proposed approach to a decentralized public key infrastructure. And the building blocks of this infrastructure are decentralized identifiers, or DIDs. A second thing we need for the infrastructure is a verifiable data registry, which ensures that we can store the DID documents and the document metadata. So with such an infrastructure in place, we can create these chains of trustworthy identifiers, where for each DID on a chain, we can trace it back to a trusted root. Now, how you can establish a trusted root is a problem in itself and won't be part of this talk, but you can find more information on that in the preprint of a paper. We have the archive link on the slide there if you're interested. So a few things to highlight in the Trustchain context is that each DID in a chain represents a recognizable legal entity, for example, central government, the Department for Health, the University of Sheffield, or something like that. In the Trustchain context, the DID documents contain public keys of the entities they represent. And the very important point is that successive entities in the chain have a pre-existing genuine relationship in real life. That means the entities know each other and trust each other and know, for example, how they can get in touch with each other. So as part of these chains you've seen, there were like things called upstream DIDs and downstream DIDs. So we first have a quick look at what those are. So a downstream DID is a DID whose document metadata contains a signature from an entity that is attesting to 2 things. First, it's attesting to the identity of the DID subject, and secondly, to the validity of the content of the DID document, and what we're particularly interested in our case, in the validity of the public keys listed in the DID document. The attesting entity, also referred to as upstream entity, is itself represented in the DID. So this ensures that the upstream entity's public keys are made available. If we have a closer look at the DID documents and metadata between upstream and downstream entity, we can see both contain a subject ID, which refers to the entity itself. Both have their public keys listed in there. A difference for the downstream in the DID of the downstream entity is that there's an attester ID, which refers to the DID of the attesting entity or the upstream entity. In the document metadata, you can see there's the attester signature. And only once we have this attester signature, we have a full downstream DID. So the role that the upstream entity plays in attesting to a downstream DID is somewhat similar to the role that the certificate authorities play for the web public key infrastructure. The difference is that the upstream entities, it's not their main role to act as a certificate authority, and they also don't want to do that. So that means any software and any process that's designed to be used for the attestation process needs to make sure that it's as smooth as possible and as little effort as possible for the upstream entity, while also being robust. And at the end of the attestation process, we want to have a full downstream DID as shown at the bottom of the slide. So the question is, how do we get there? And for this, we developed a challenge response protocol that underpins the attestation process in Trustchain. So to reiterate, the attestation process has two parts. We need to attest to the identity of the DID subject and to the validity of the public keys in the DID document. And we accordingly split the challenge response protocol in two parts. So first of all, we look into the challenge identity challenge response. I should mention that most, but not all parts of the challenge response protocol are intended to be done using the Trustchain software client that we're currently developing and implementing. So the scenario we have here is that both the downstream entity and the upstream entity have a Trustchain software client running. In addition, the upstream entity is also running a Trustchain server to provide service endpoints that the downstream entity can ping. So step 0 here, the preliminary step, actually happens outside of Trustchain using alternative communication channels. In this step, the downstream entity gets in touch with the upstream entity and requests an API access token. The main purpose of this access token is to prevent denial of service attacks. The reason why we can do this using an alternative challenge is to go back to the beginning is because these two entities are known to each other and they have already a pre-existing relationship. So they know how to communicate with each other. So once the downstream entity receives the access token, it can start to initiate the DDID request by using the upstream entity service endpoint. The service endpoints, I forgot to mention, this can also be found in the DID document of the upstream entity. So for this request, the downstream entity has to provide a few things. It has to provide the access token, the name of the downstream entity, a name of an individual operator who's at the downstream entity who's responsible for this request, and a temporary public key. This temporary public key is part of a temporary key pair generated by the software, which will be used throughout the challenge response process. But it's not the public keys in the DID documents. They're only, the temporary keys are only used for the challenge response part. So on side of the upstream entity, all requests that don't have a valid access token are automatically declined. For all remaining requests, if the upstream entity recognizes the name of the downstream entity and also the name of the provided name of the operator, they accept the request. The upstream entity then generates a random number, a nonce, which it encrypts with the temporary public key and signs it with the upstream entity's public key and send this encrypted and signed nonce back to the downstream entity together with an update commitment. I'll talk a bit later about what this update commitment means and what its purpose is. So again, as you can see from the dashed lines, this step 2 again happens using alternative communication channels and not the Trustchain channels. So in step 3 now, the downstream entity has to prove that they received the nonce. The downstream entity decrypts the nonce, signs it with the temporary private key, and encrypts it with the upstream entity's public key. This is then sent back to the upstream entity who verifies the signature and the value of the nonce. And what we achieved at the end of this identity challenge response process is that we tied this temporary public key to a real world legal entity. So that's the end of part 1. What happens now is that the downstream entity can publish their candidate DDID. It's a candidate DDID because it still lacks the signature, so it's not a full DDID, but otherwise all the required fields are provided, including the update commitment that I mentioned before. So a quick note on the update commitment. The upstream entity needs to be able to revoke, update, or renew the DDID. And to do this, they need to provide an update commitment to basically prove that they are allowed to perform these operations. But at the same time, the downstream entity must remain in ultimate control of their identity. So that means both the downstream entity and the upstream entity are both controllers. So that's the term that's used by the W3C standard. They are both shared controllers of the DID. And that's simply the reason why the downstream entity needs to include this update commitment already in the candidate DID. And the update commitment comes from the upstream entity. So as mentioned, the piece that is missing now is the signature from the upstream entity attesting to the downstream DID. And to get the signature, the downstream entity needs to start part 2 of the challenge response protocol, the content challenge response. As a reminder, the aim of this part is to verify the validity of the public keys in the DID document. So I talk you as before through the steps. So in step 1, the downstream entity pings the upstream entity service endpoint and provides the temporary public key along with the now published candidate downstream DID. The upstream entity now needs to establish that the downstream entity is actually in control of the private key counterparts of the public keys listed in the candidate DDID document. And to do so, they present a challenge to the downstream entity in form of another nonce, which the upstream entity encrypts with the temporary public key and signs it with their own public key and sends it back to the downstream entity. In step 3, the downstream entity decrypts the nonce and signs it with their with each public key listed in the DID document. So the signed nonces are then re-encrypted with the upstream entity's public key, and this response is posted back to the upstream entity. I know there's a lot of encryptions and signings and keys going on. So the upstream entity now takes the response, decrypts the nonces, checks if the value is okay, and checks the signatures on the nonces. So, and with checking the signature, they verify the public keys of the downstream entity. And if all the checks pass, the upstream entity finally performs the attestation by signing the DDID and publishing the full downstream DID, which then looks, just as a reminder, now we have in the bottom right, the DDID document metadata also includes the tester signature, and we have our full downstream DID.